So in a previous video, we looked at this problem using the p-value approach. Right? So in this video, I'm going to show you how to do this exact same example using the critical value approach. So the first step is the step where we develop the null and the alternative hypothesis. That's what we did in the previous video, so I'm not going to do it again. Right, so we developed the null hypothesis and the alternative hypothesis, and then we list everything we know, right, from the problem. In the second step, we calculate the test statistic. Right? So when sigma is known, the test statistic, z is calculated using this formula. So x bar minus mu sub 0 divided by sigma over the square root of n. Plugging in numbers gives you a value of -2 for the test statistic. Let's now move on to the third step. And the third step is the step where we formulate the decision rule. Right? So we formulate the decision rule, and in this video, we're going to use the critical value approach. And from now on, instead of writing critical value, I'm just going to write CV. Okay. First, let's note again that alpha in this case is 1%, which is equal to 0.01. So nothing new there. Let me now define z sub alpha as the z value or the z-score such that the area under the standard normal curve to the right of it is alpha. Okay. In other words, if you draw the standard normal curve, right, and if this is your z sub alpha, then the area to the right of it, the shaded area here, is equal to alpha. Okay. Now we're ready to formulate our decision rule. For a lower tail test, we reject the null hypothesis, so we reject h sub 0 if our test statistic is less than the critical value, where the critical value is equal to negative z sub alpha. So let's go ahead and move on to step 4 and try to reach a conclusion. So we know that our test statistic z is equal to -2. Now we just need to find what the critical value is. The critical value in this case is equal to negative z sub alpha, which is negative z sub 0.01. Right. In other words, you want to find the z value such that the area to its right is 0.01, and then find the negative of that value. the negative of that value would be our critical value in this case. Okay, so you want to find the z value such that the area to its right is 0.01. In order to use the standard normal table, you're going to have to find the value to the left of the z, right? So, which is 1 minus 0.01, which is equal to 0.99, right? So the idea is we go into the standard normal table, look in the interior of the table for 0.99, then trace it out horizontally and vertically to get a value for z sub 0.01. Let's do that. If you go to the standard normal table, you want to look for 0.99 in the interior. It's not going to be 0.99 is not going to be on here, so you want to go to the next closest thing, right? And the next closest thing to 0.99 is 0.9901, right? If you trace it out horizontally, you get 2.3. If you trace it out vertically, you get 0.03, and so z sub 0.01 is going to be equal to 2.33. In other words, the z value such that the area to the right of it is 0.01 is 2.33. So let's go back to our problem. We know that this is 2.33, and so our critical value is going to be negative 2.33, negative of that number, right? Okay. So our test statistic is negative 2. Our critical value is negative 2.33. So in this problem, our test statistic of negative 2 is greater than our critical value of negative 2.33. Right? So our conclusion is that we cannot reject the null. Now, if you recall the conclusion using the p-value approach, right? In the previous video, when we use a p-value approach, we said that the p-value was 0.0228, which is greater than 0.01. So what was our conclusion? Our conclusion was that we cannot reject the null. Okay, so we couldn't reject the null then. We can reject the null now. So regardless of which approach you use, you should reach the same conclusion, right? For a given problem.